Okay, today we're talking about exponential and logarithmic equations. So first off, let's make sure everybody knows what an exponential equation is. An exponential equation is any equation with a variable in the exponent. And it can be solved in one of two ways. So before I talk about which way it can be solved, so think about that exponential equation is something 2, well that says 3, okay, 3 to the x equals 9. My variable is in the exponent. It is not something that is x squared equals 9. So this is not the type of what we're working on right now. We're working on these kind that have the variable up in the exponent. There's two ways that we have to solve them. One is to write both sides of the equation with a common base. Okay, I'm having a little trouble here. With a common base. The other way is to take the log of both sides. So let's look at it and we'll determine when we need to do which method, when we need to use which method. Okay, so to start off with, we have what is the solution of 27 raised to the 3x equal to 81. Okay, our goal, and it's always going to be easiest if we can write both sides with a common base. So can you write 27 and 81 with the same base? Hopefully you've learned your powers and you know that 27 is the same thing as 3 to the third, and 81 is 3 to the fourth. So I have now written both sides of my equation with the same base. Now what do we do when we raise a power to a power? We multiply, so this side becomes 3 to the 9x equals 3 to the fourth. And now that I have two expressions equal to each other that have the same base, then I can go ahead and set their exponents equal to each other. So I can ignore the bases, set them equal. 9x equals 4, divide both sides by 9, and I get x equal to 4/9. And that's my answer. Okay, let's try the next one. What is the solution of 5 to the 2x equal to 130? All right, can we write, that's already a base of 5, can we write 130 as a base of 5? Okay, we cannot. Okay, so in this case, there is no common base. So if there's no common base that you can write your both sides of your equation in, then that means that you're going to take the log of both sides. And you can take that log in any base that you want to. We generally use base 10. That's the button on our calculator. So that means that the log of 5 to the 2x equals the log of 130. Now, what next? We need to apply our power rule. Okay, and if we have the log of that argument having being a power, then I get to move that in front. So this is going to become 2x times the log of 5 equals the log of 130. Now, I'm trying to solve this for x. That means I need to get rid of everything except for the x. So I'm going to divide both sides of my equation by anything being multiplied by the x, which happens to be 2 log 5. So I'm dividing both sides by 2 log 5. And log 5's cancel, the 2's cancel, leaving me with x on the left side of my equation. And I will put that in my calculator. Now keep in mind, this is an operation, so when you put it in your calculator, depending on what you have, you might need to put parentheses around that before you enter it in. So pause if you need to, then come back and we'll see what we get for an answer. X equals approximately 1.5122. All right, let's do a few more of those. What is the solution of each exponential equation? Check your answer. So again, I cannot write 800 with a base of 7. So the first thing I need to do is to take the log of both sides. So I'm going to take the log of 7 to the 4x, and that's going to equal the log of 800. All right, hopefully you remember that we're going to use our power rule, and that means 4x times the log of 7 equals the log of 800. Keep in mind when you're doing this, this is just a number. The log of 7 is a number, the log of 800. We carry it through the problem like that and we don't put a decimal because it just rounds things and makes our answer not as accurate if we save it to the end. But just remember that it is a number, it is not a variable. You put it in your calculator and you're going to get some decimal value. Okay? So again, as we did before, we're going to divide by 4 times the log of 7, divide both sides. 4 times the log of 7. Put that in your calculator, and over here, might need to put parentheses there. So we get that x equals approximately, pause if you want to do it yourself first, 0.8588. Okay? Check your answer. If you will leave your calculator, leave that in your calculator and don't do anything to your calculator, then you can check it on your calculator by putting 7. Most of y'all have the kind where you use the little caret button, and then you're going to put parentheses 4 times the answer, however you retrieve that answer, and then push equals. Then you should get 800 on your calculator. So that's a way to check it and know whether or not you've got the right answer. Okay, look at the next one. Okay, 5.2 to the 3x. Again, take the log of both sides because I cannot write 400 with a base of 5.2. So I have the log of 5.2 to the 3x equals the log of 400. Use my power rule. It's going to say 3x to the log of 5.2 equals the log of 400. And hopefully you can tell me that I'm going to divide both sides by 3 log 5.2. 3 log 5.2. And when you put that in your calculator, if you have a certain kind, make sure you put parentheses there. And your answer is going to be, pause before I calculate. Okay, hopefully you all got an answer of x equal approximately 1.2114. And again, to put that back in your calculator, okay, if you leave it like that, then go on your calculator and do 5.2 raised to whatever your exponent button is, parentheses, 3 times your answer. And of course, that should equal 400. And it did on mine, so we're good to go. And I got to box that answer. Okay, on to a word problem. What is a sustainable, renewable natural resource when you manage forests properly? Your lumber company has 1.2 million trees. You plan to harvest 5% of the trees each year. How many years will it take to harvest half the trees? Okay, this is an exponential growth problem that we have had in the past, and our formula was a sub t equals a times 1 plus r to the t. All right, we are looking for how many years will it take to harvest half the trees. So hopefully y'all can figure out that half of 1.2 million is 600,000. So we'll put 600,000 over here. And we of course started with 1.2 million. 1.2 million. I have one. Now, I'm harvesting the trees. Does that mean hopefully you realize that if we're going from 1.2 down to 600,000 that this is going to be a minus 0.05%, or zero point zero 0.05 equals 5%. And we're trying to figure out how long. We don't know what that is. So if I divide both sides, I've got zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm left with 6 and 12. And if I divide both sides by that 12, then I'm going to get 1 half is equal to 0.95 to the t. Okay, so before we actually used our calculator to do it, but now we know how to solve this problem. So what we're going to do from here is take the log of both sides. And if you would prefer, we can put 0.5. Log 0.5 equals the log of 0.95 to the t. That makes our next step using our power rule. So we have the log of 0.5 equals t times the log of 0.95. And hopefully you realize that means we're going to divide both sides by the log of 0.95. So punch that in your calculator. Should be a pretty direct answer. Uh, Pause if I'm going too fast. Make sure you can put that in there correctly. When you put it in there, you get about approximately 13.51. So how many years will it take? We'll say 13.51 years. Okay, sometimes your equations, or the second part of what we're supposed to talk about today, is logarithmic equations. Okay, so our logarithmic equations, we have one log in our problem. We have the log, let me go highlight this so you can make sure you tell what we're solving. This part right here. There's my equation. Log of 3 minus 2x equals negative 1. Okay, you're going to solve this problem. Okay, when you have only one log, you're going to use what we referred to earlier as the definition. So hopefully you remember the definition. If we had the log base b of x was equal to y, if and only if, so that meant we could go either way with this, if, and we use a little kick out, b to the y equals x. Okay, so that being said, what is my base here? Okay, you should all remember that that's a base of 10. So I'm going to write 10 to the negative 1 equals that thing. So 3 minus 2x equals 10 to the negative 1. Well, what is a 10 to the negative 1? Oops, a little too fast there, sorry. 10 to the negative 1, hopefully. So we have 3 minus 2x equals 1/10. I'm solving for 2x, so I'm going to subtract 3. So I have negative 2x equals 1/10 minus 3, which is negative, I'm going to put it as a decimal now, negative 2.9, because it terminates. And then we're going to divide both sides by 2, negative 2. And when we do that, we're going to get that x equals 1.45. Again, if you want to check it, okay? And you really should. 2 times 1.45 is less than 3. So you put that in your calculator, punch the log of it, and you'll get an answer of negative 1. Okay, last problem. Similar situation, but this time, okay, I don't have just one log. I have two on that side of an equation. So we have to use what we learned in the last section to condense these two. And if I have two logs that are being subtracted, then I can bring them together by the division property. So that means that this is going to be equal to the log of 6 over 3x, and that is equal to negative 2. And then from here, I'm going to use my definition, because I have just one log. So that's 6 over 3x equals 10 to the negative 2. And then that's going to be 6 over 3x. 10 to the negative 2 is 1 over 10 squared, which is 100. So I have a proportion I'm going to cross multiply, giving me 600 equals 3x, and divide both sides by 3, and we'll get an answer of x equals 200. Again, you can put it back in there and check it with your calculator if you want to know if you got it right. And that sums up exponential and logarithmic equations.